Well, all right, we're going to be looking at solving inequalities by multiplication and division. And kind of like what we did with addition and subtraction, it's pretty much like if we were solving an equality or solving an equation. However, there is one big burn notice. So what do you think? What is a burn notice? Well, a burn notice is something that will trip you up, and here it is. If you have to divide or multiply by a negative number, you have to flip the inequality. So let's see. Well, and this is a big one. So if I've got to solve the inequality by dividing or multiplying by a negative number, I have to change the sign, or I'm going to say that you got to flip the inequality. Now, that means if it was a less than, you got to change it to a greater than. If it was a greater than or equal to, you got to change it to a less than or equal to. So, let's emphasize this one more time. We got it here in writing. I've said it now 3 times. Burn notice. If you have to divide or multiply by a negative number when you're solving an inequality, you've got to flip the inequality. All right, well, let's look at a couple of examples here. You can see here that I've got an inequality that says negative n over 6 is less than or equal to 8. Now, that negative sign I can attach either to the n or I could attach it to the 6, because let's say if I took n and divided it by negative 6, well, that's negative n over 6. And if I had negative n over 6, well, that's negative n over 6. I'm still dividing, in this case, a positive number by a negative number. I'm going to end up with a negative number. Positive, negative is going to be negative when I'm multiplying or dividing. Okay, but I want to attach that negative sign to the 6, not the n, because I'm solving for n. I'm not solving for negative n, I'm solving for n. Okay, so let's go through trying to solve this. Now, if I'm dividing n by negative 6, and I want to isolate the n, that means I'm going to have to multiply both sides of this by negative 6, both sides of the inequality by negative 6. So here I got n over negative 6. I'm going to put that in parentheses. And I've got 8 over here that I'm going to multiply by negative 6. Now, but what about my inequality? Well, I started off, I'm sitting here to begin with less than or equal to, but I am multiplying by a negative number, so I've got to change that, flip that to greater than or equal to. Now, let's go ahead and solve. Negative 6 over 6, well, that's going to just cancel out to be 1. It's going to leave me with n. So now n is greater than or equal to, and 8 times negative 6 is negative 48. All right. Now, if I'm asked to graph this on the number line, let's say that right here is negative 48. Okay. And n is greater than or equal to negative 48. Well, it's a greater than or equal to, so you may remember I got to have a closed dot here. And if n is going to be greater than negative 8, I'm going to move to the right. My graph's going to move to the right, and it's going to look something like that. Now, if I were to write this in set builder notation, I'd have my bracket, and I would have n such that n is greater than or equal to negative 48. And there I go. Done. All right, let's look at this second example. Now, here I got 1/5 n is greater than or equal to negative 3. Now, that would be the same thing as if I wrote it as kind of like what we did up here. If I wrote it as n over 5, I'm dividing n by 5. If I'm multiplying 1/5 times n, that's the same as dividing n by 5. And to solve this, I am going to multiply both sides of the equation by 5. So here I got 5 times 1/5 n And over here, I'm going to multiply negative 3 times 5. Now, what about my inequality? Well, started off, I'm greater than or equal to, and I'm multiplying by a positive number. Now, I could get tripped up over here because I see that negative 3, and I might think, oh, I'm multiplying by a negative number. Well, I am multiplying 5 times a negative number, but I am not solving this by multiplying by a negative number, if you catch what I mean. This is a positive 5. So I am multiplying here by positive 5 on both sides, and my inequality is going to remain the same. And as we solve this, 5 times 1/5 is just going to equal 1. It's just going to give me n greater than or equal to, and then negative 3 times positive 5 is negative 15. So once again, if I've got this on a number line, and let's say I've got negative 15 right here, and in this case, once again, n is greater than or equal to, I'm going to move it to the right. My arrow is going to the right. If I got to have a closed dot or open dot, well, I got to have a closed dot because it's greater than or equal to. And if I write that in set builder notation, I got n such that n is greater than or equal to negative 15. All right, that gives you a couple of examples of multiplying, solving an inequality by multiplying. And one, you're multiplying by a negative number, which you flip the sign. And the second example, we multiplied by a positive number, and the inequality symbol remains the same. All right, let's solve a couple of inequalities by using division. So let's look at this first one right here. I've got 8p is less than 58. So I got 8 times p. And so in order to isolate the p, I'm going to do the inverse of that multiplication. I'm going to divide. The inverse of multiplication is division. So let's start right up here. Let's see, I got 8p is less than 58. Okay, I'm going to divide both sides of the inequality by 8. So it's going to leave me with p. Now, is my inequality symbol going to stay the same, or do I have to flip it? Well, it's going to stay the same because I am dividing by a positive number. So I'm still going to be left with p is less than, and let's see, 58 over 8. Let's see, 8 times 7. 8 times 7 is 56. So it's going to go into, 8's going to go into 58 7 times. And 58 minus 56 is 2, so that's 2 8s. And of course, 2 8s is 1/4. So let's write this. P is less than 7 and 1/4. Now, say I'm going to graph this on the number line. And let's say we got 7 here, we got 8 here. Let's say we got 6 here. Well, P is less than 7 and 1/4. So let's see, I'm going to estimate that 7 and 1/4 is right about there. Now, am I going to have to graph this with an open dot or a closed dot? That's my first question. Well, it's going to be an open dot because it's just a simple less than, not a less than or equal to. And if P is less than 7 1/4 or 7 1/4, then I'm going to move to the left on my number line. And so there's my graph. And if I write this in set builder notation, I got a little bracket there. It doesn't look much like 1. P is such that P is less than 7 and 1/4. Okay. Now let's look at this second example. I got negative 42 is greater than 6r. Well, I'm going to start off just like it shows me. And so if I've got negative 42 is greater than 6 times r, and I want to isolate the r, so here I'm multiplying 6 times r. It means I got to do the inverse. So I'm going to divide both sides of the equation by 6. And over here I got 6r divided by 6. Now, what about my inequality? Well, I'm dividing by a positive 6, so my inequality is going to stay the same. And even though I'm dividing 6 into a negative number, I still keep my inequality symbol the same because what I am dividing by is a positive number. So 6 will go into negative 42, negative 7 times. And here the 6 and the 6 cancel. So it's -7 is greater than R. Now, that's pretty cool, except I really want to rewrite this with the R on the other side. So I'm going to do that R now. And I got -7 over here. But what do I do with this inequality when I flip the whole inequality around? Not just flip the inequality symbol, but flip the whole inequality. Well, what I've got to watch for is which way is this arrow. If I think about the less than or greater than as being an arrow, where's the small end? Well, the small end is pointing towards the R. And so I need to leave it just like that. So I'm going to write it like this, with that small end pointing towards the R. Now, if it'd been -7 is less than R, and I'm rewriting it, I would then put R is greater than -7. So whichever way is the open end, closed end. If you look at it, the open end is pointing towards the -7 here. The small end is pointing towards the R. And when I rewrote that, the small end is pointing towards the R, and the open end is pointing towards the -7. That could get a little confusing. It's another burn that's involved in all this. Let's put this on a number line right quick. Okay, let's say -7's right here. Okay, and we're saying the R is less than -7. Okay, let's think about this. Am I going to do a closed dot, open dot? Well, I've got to do an open dot because it is just a simple less than. And if R is less than -7 on my number line, I'm going to move it I'm going to graph it to the left, and it's going to look something similar to that. And again, if I put this in set builder notation, I've got R such that R is less than -7, and we've got it. All right, there's a couple of examples. You really got to get some practice on this. Make sure that you keep your inequality symbols the way they need to be. Do I flip it or not? It's going to depend on whether you multiply or divide by a negative number. And second part, as we saw in this very last example, if I rewrite it by reversing where the variable is, I got to keep my inequality symbol pointed in the same direction as it was when I solved it. So if my inequality symbol has the narrow end or the pointed end pointing towards the variable, when I rewrite it, I got to keep it pointed to the variable. That means that in itself is going to flip the inequality. But I'm actually flipping not just the inequality symbol, I'm flipping the entire inequality. If you have any questions, you make sure you ask.